Channel, a special presentation. The greenhouse effect, acid rain, the diminishing ozone layer. These man-made problems are changing our world sooner than we ever thought possible. Stay tuned as we look at the powerful forces that have pushed us to the edge of a global crisis.
In the span of a human lifetime, our planet can appear static, as constant and invariable as rock. In a human lifetime, it's easy to feel that the environment we are familiar with will remain unchanged through our lives and our children's lives, and so on. But let us shift our perspective and view our planet across the span of geologic time, where a planet exists for billions of years. We find that Earth is actually incredibly dynamic. It is a living ecosystem which is constantly evolving. Industrial man has built a culture based, it seems, on a static view of Earth. The perspective allows us to progress according to our wants, our needs, and our creativity without much concern for the consequences to our environment. And so it has been. But in the summer of '88, alarm bells sounded. Record heat and drought affected 48 of our 50 United States. The weather became front-page news as we learned that this might be the beginning of a permanent climate change. Global warming brought on by man's burning of fossil fuels. The consequences of our actions seemed to be staring us in the face. We wondered if we were on the threshold of a global environmental crisis. What has happened since the summer of 1988? Although the drought broke and the headlines changed, the environmental problems they brought to our attention haven't disappeared. This program looks at 3 of the environmental threats that pushed to the forefront in 1988. We'll explore how they may be interacting with the Earth's own dynamics to change our world. We'll start with the greenhouse effect. The greenhouse gases, carbon dioxide, methane, and other trace gases make up only a tiny fraction of our atmosphere, yet they have a profound effect on Earth's heat balance. Without them, our planet would be a lifeless, frozen desert. A certain quantity of greenhouse gases are always present in Earth's atmosphere. They allow sunlight through to warm the surface of the Earth. They also prevent some of the heat from escaping back into space, so they have helped keep Earth's surface temperatures at an average 55.4 degrees Fahrenheit for thousands of years. Since the early 1800s, industrial burning has increased greenhouse gases by 30%. More greenhouse gases mean that while sunlight still enters the atmosphere, more heat gets trapped, and the Earth grows warmer, theoretically. 1988 went on record as the warmest year in the last 100. The next 5 warmest years also occurred in this decade. Scientists believe that a natural climate phenomenon known as El Nino is at least partially responsible for the extreme warming seen around the globe in 1988 and other years. While we lack proof positive of a warming trend at this point, many scientists say their educated guess is that the greenhouse effect is underway.
The world is indeed about 1 degree Fahrenheit warmer than it was a century ago, and that amount of warming is consistent with what scientists would predict given the amount of greenhouse gases such as carbon dioxide that have been added to the atmosphere over the period. We can find no other reason why the world would have warmed by 1 degree Fahrenheit over 100 years, so it's reasonable to assume that this warming is in fact caused by the increasing greenhouse effect.
Other scientists, such as Dr. Patrick Michaels of the University of Virginia, believe that the greenhouse effect should have caused greater warming by this point.
It hasn't warmed up as much as it should have, and that's the real problem with the greenhouse dilemma. Our computer models tell us it should have warmed up between 3.3 and 3.6 degrees Fahrenheit by now as a result of all these gases. Now, we know some of that warming has been slowed down by the ocean, but even when we consider that, it appears that it hasn't warmed up as much as it should have.
We're seeing some of the expected greenhouse signals: thinning of polar ice, retreating glaciers, and rising sea levels. But we are also seeing some surprises. Scientists had predicted greenhouse to bring either uniform warming of the atmosphere or greater warming at the poles. Instead, we have seen an increase in tropical temperatures. The wider contrast between polar and equatorial temperatures has brought about the most extreme weather seen in 300 years. Wild swings from hot to cold and from wet to dry weather. Another surprise is that the hemispheres are warming at different rates.
The southern hemisphere is the one that's showing the signal that looks more like the greenhouse effect, where it's warming up quite rapidly. The northern hemisphere shows no net warming since the 1930s. And the disparity between those two hemispheres is cited as one of the principal problems in our understanding of this effect. Earlier I said that the oceans should be slowing down some of the warming. Well, the southern hemisphere is a hemisphere that's almost all water. Why is that the one then that's showing the signal more than the northern hemisphere?
Scientists are also debating the type of climate we'll see as greenhouse progresses.
I could give you an example of the complexity that we're looking at. Averaged over the United States, high temperatures now are running as low as they have for the last 100 years. What's happened is that the nighttime temperatures appear to be coming up relative to the daytime temperatures. And some people say that, in fact, might be the way greenhouse world would express itself. Now, our climate models do not discriminate at this point in time very well between day and night, so we just have to take a look at the data that we have. If greenhouse world is one where nighttime temperatures come up and the daytime temperatures don't change, that's a radically different world from the one of sand dunes in Kansas that people paint. It's a world where the growing season's longer, the crops grow better, etc. So this shows you how little we know about what the future is going to bring.
If if the predictions of the climate models are correct, and if the emissions of the greenhouse gases continue, summers in the 1990s should be hot more frequently and noticeably so if these emissions continue. If you want to understand what the future could look like in, say, 40 or 50 years, one has to only look at what happened last summer. Last summer was a very hot summer, but it looks like it could be just a typical summer by the year, say, 2030.
Are you frightened?
This sort of thing worries me greatly. I think that that the world is moving into a period of continuous and rapid change, that neither human beings nor societies nor natural ecosystems are built to deal with such changes. And therefore, I see a period coming which is extremely difficult for human beings and in which natural ecosystems have no future at all.
We have yet to feel the full impact of the greenhouse gases man has dumped into the atmosphere over the past century. And each day, the industrialized nations continue to generate billions more tons of them. Now the developing nations stand poised to begin massive exploitation of fossil fuel technology. Meanwhile, deforestation, the other major contributor to greenhouse gases, continues to accelerate. World policymakers are beginning to consider curbing emissions of greenhouse gases. While some suggest waiting for more definitive answers about greenhouse, others warn that delay only increases the amount of climatic change we'll have to deal with. Because once Earth warms, there is nothing man can do to cool it off again. One of the more observable results of global warming would be an increase in sea levels. As a matter of fact, the Earth's oceans are already on the rise. What will be the consequences for our heavily populated coastline?
Why does something so rewarding have to hurt so much? Well, now it doesn't. Thanks to the revolutionary new Scoot and Do utility cart. Now for only $59.95, put an end to needless crawling, bending, and stooping. Scoot and Do makes tending your flowers, gardening, and weeding painless. Plus, it's perfect for painting and cleaning indoors and out. Baseboards, kitchen cabinets, boat bottoms, and cars have never been easier. Scoot and Do has dozens of uses. With its heavy-duty wheels, it rolls on any surface inside or out. With its comfortable padded seat, roomy tool carrier, and sturdy construction, it'll provide years of service. If working down low makes you feel low down, you owe it to yourself to try the Scoot and Do utility cart. Here's how to order.
To order your Scoot and Do utility cart, call 1-800-535-3800 or send check or money order for $59.95 plus $8 shipping and handling to Seasonal Solutions, P.O. Box 6348, FDR Station, New York, New York, 10150.
10 minutes past the top of the hour, a severe thunderstorm watch is in effect until 2 p.m. Central Standard Time for the eastern portions of Kansas, including the cities of Emporia, Salina, and Fort Riley. Take a look at this local radar out of Wichita, Kansas, depicting the heavy thunderstorms in the area. A severe thunderstorm warning is in effect for Dickinson County, Clay County, and Butler County. Here's a look at your local forecast.
The last rise in global sea level came at the end of the last ice age, about 18,000 years ago. As the Earth warmed, the seas expanded and covered more land. For the last 4,000 years, ocean levels have remained fairly constant, but they began rising again in the 1930s. Scientists are questioning if the rise is being triggered by greenhouse warming. If the increase in sea level continues, what will happen to New York, Miami, Los Angeles, and other major population centers?
Well, the state of Louisiana offers a preview. In most places, the sea is rising at the rate of 1 to 1.5 feet per century. But Louisiana is sinking, increasing the rate to about 4 feet per century. As John Hope reports, people there are already feeling the effects.
New Orleans, an American treasure. It's one of a handful of American cities that values and protects its history, and in a way, is threatened by its own past. The famous French Quarter is what most tourists know of the city, and there's much to be learned about New Orleans here. The French Quarter was New Orleans at first. It was built on a natural levee. Its streets were established along canal routes. The city blocks in the French Quarter were known as islands.
New Orleans exists as it does because of water. Water in huge amounts. Established here in 1718 because of the Mississippi River, it is now the largest seaport in the United States in terms of tonnage handled. There's water all around the city, and 40% of New Orleans is below sea level.
Well, if you look, as you look in New Orleans, recognizing it was established in 1718, keeping in mind there were no levees here at all, the water level, even in a year when we are at as low as we've been in 50 years, is still at about the first floor level. So at flood stage, which will take place in September, October, you can see that the river will be actually, another 10 to 20 feet up the levee, which would, in that case, flood most of the city.
Coastal geologist Don Davis and Shay Penland were our guides in Louisiana. They're concerned about New Orleans and the threat of a rising sea level. And though our trip began in the city, the threat begins several miles south of there. and the deltas, marshlands, and barrier islands.
Well, New Orleans is threatened in the sense that the more marsh there is in front of New Orleans, the greater protection that city has, particularly from a hurricane. Without that marsh, then the city is certainly vulnerable to hurricane damage. The city is already protected by an enormous levee system and pump system that's designed to drain a city that's not only at sea level, but partially below sea level. So New Orleans and the citizens in the greater New Orleans area are in many ways at risk.
The marshes and barrier islands Davis is talking about are some 50 miles south of New Orleans. We visited Cocodrie, a town in Terrebonne, or Good Earth Parish. The Louisiana University's Marine Consortium is located here, overlooking the life-filled marshland. This area is an important stopover for migrating birds. It's also the most important source of shrimp in the United States. As much as $200 million worth a year come from Louisiana. Houston Foray runs a shrimp processing plant in Cocodrie. He and his family have lived in Bayou Petit Caillou for generations.
Yeah, I was born right across the bayou from here, just about half a mile from here on the end of the point in 1938, September 9th. And so I never moved out of Cocodrie, so you could say that I'm probably, like some of the people over here call me the mayor of Cocodrie, in fact. When I was a kid, we used to go to the beaches with my father when I was just, 7, 8, 9, 10-year-old, stuff like that. We had an island used to be called One Island. And One Island was probably an island that probably was about, rough guess, 8 miles long. And now there is nothing left of that island. I mean, it's completely gone.
South of Cocodrie, near where One Island used to exist, are the Denier Islands. The name is ironic. In English, that means last island. Several government agencies are studying erosion on the Denier Islands. Denise Reed works for the Louisiana University's Marine Consortium. She's studying the erosion of Louisiana's wetlands. She'd not been to Denier Island for 6 weeks.
It's changed enormously. The last time I was here, that pole that's now sitting down there at the top of the waves was just at the top of the beach there, where the wave staff now is. And that line of posts going out in front of the pole there, well, when they were first put in about 2 years ago, they were on the top of the beach, like where we're standing now, and they were just sticking up about half a metre or so. It's changed enormously just in the last 6 weeks.
Denier Island, the whole barrier island system, in fact, has been changing for years. This was the west end of Denier Island in 1984. This video is part of Louisiana State University's annual aerial survey. The same area in 1988. Without reclamation efforts, these islands have only about 25 years left. But Terrebonne Parish reclaimed the east end of the island. This is how it looked before reclamation in 1984. And this is how it looks today. The reclamation's been a huge success. A part of Shay Penland's research at Louisiana State University is to tape these aerial surveys. He's a soft-spoken man, but enthusiastic about the success of this kind of project.
So what you see here is what we call a restored barrier island. Sediment was basically pumped onto the island. Basically a large basin was constructed by earth-moving equipment, and sediment was pumped from offshore into the settling basin. The material basically filled an area and built the island from an elevation of about 1 foot, 2 feet, and an elevation of about 7 or 8 feet. After the material had been deposited in this retaining basin, it was about 1 mile long and 1,000 feet wide, and it cost about $800,000 to build it, about $250 a linear foot.
The erosion problem is everywhere along the Louisiana coast. Evidence of it is dramatic. This Civil War era fort was built to guard the inlet between islands. The sea is winning the battle. Seawalls built 15 years ago to keep back the water on East Timberler Island are now submerged in it. And the replacement seawall will be gone in about 2 years. The extreme sea level rise in Louisiana is due more to the sinking of land than the rise of the ocean. But if we add the greenhouse effect to the natural subsidence, Some experts predict the sea will rise as much as 10.5 feet in Louisiana in less than 100 years. The yield and year have less time than that. In 50 years, this area will look like
open Gulf of Mexico. It'll simply be open water. We already recognize that we're getting significant opening of our bays. In Louisiana, we lose, again, partially because of the greenhouse effect, partially because of natural processes. We lose about 50 square miles of land area a year. Every 5 years, we lose the equivalent area of Orleans Parish. Or if put it this way, every 15 minutes, we lose 1 football field on average.
Here's what those predictions look like on paper. By 2085, the Gulf of Mexico will be lapping at New Orleans levees. Houston Foray's home, Cocodrie, will be gone. Foray understands what's coming.
I may not see that, but my kid or my grandkid will probably see that at the way that erosion is going right now, I'd say in another 100 years or so, probably there won't be no more Cocodrie, or probably your next port will probably be the city of Houma.
And what does that mean for his kids and grandkids?
Well, they're going to have to be like everybody else. They have to hit for higher ground.
Heading for the high ground may be an option for escaping rising waters, but it's difficult to run from something you can't see. Ultraviolet radiation is an invisible threat to life on Earth, and we're losing our sole protection against it.
Gardeners, if you love fresh-tasting vegetables and big, beautiful flowers, but think results like this take too much time and too much back-breaking work, here's great news. Introducing the affordable Troy-Bilt Junior, designed especially for smaller gardens. Just look at the time and work the Junior will save you. It's so easy to prepare perfect, ready-to-plant seed beds. Plus, working organic matter into your soil is a snap. Spot till areas for beautiful flower gardens and borders. Why, you can even use the Junior to reseed your lawn or ring fruit trees. You'll be amazed at how much time and work the Junior will save you. So if you want to learn more about getting results like this, the fast, easy Troy-Bilt way, call now to receive your free Troy-Bilt catalog.
For your free catalog featuring the Junior and our whole line of Troy-Bilt tillers, including our no money down easy payment plan, call toll-free 1-800-441-3434. Operators are standing by. That's 1-800-441-3434. Call now.
Earth is constantly bombarded by ultraviolet rays from the sun. Our sole defense against these deadly rays is stratospheric ozone. In 1985, scientists discovered a massive hole in the ozone shield above the continent of Antarctica. In 1988, they were able to offer definite proof that the destruction is man-made. John Doyle reports.
It begins in mid-August when the sun reaches returns to relieve the dark Antarctic winter. But spring here is no longer a time of rebirth. It is a season of destruction. By mid-September, a hole of spectacular proportions will have developed in the ozone layer above Antarctica, an area of stratosphere larger than the continental United States, in which there will be a massive loss of ozone, the protective filter that makes life on Earth possible. Ozone, a simple gas molecule consisting of 3 atoms of oxygen. It accounts for only 3 of every million parts of stratosphere. The so-called ozone layer is simply a scattering of these molecules, yet it manages to protect us against deadly amounts of ultraviolet radiation from the sun. As we lose ozone, greater amounts of UV radiation will reach Earth. It will damage crops and other vegetation and kill plankton, the foundation of the aquatic food chain. In humans, it will cause more skin cancers and may damage our disease-fighting immune system. We discovered the hole in the ozone above Antarctica in 1985. We now know that it has appeared there every August for the last 10 years. We also know that the so-called hole represents a major loss of ozone from the region. In late August 1987, a team of scientists led by NASA made a series of flights directly into the hole. They were searching for answers about its cause. One of their most important experiments measured high concentrations of chlorine monoxide within the hole, levels 500 times greater than those found at other comparable points in the atmosphere. Chlorine monoxide is key to the chemical process which destroys ozone. The disproportionate amount found in the hole was unquestionable proof that chlorine from man-made chlorofluorocarbons initiates the destruction of ozone here each spring. Chlorofluorocarbons, or CFCs, are a group of chemicals used the world over. We've applied them to everything, from aerosols to air conditioners, from foam containers to cleaners for our computer chips. But the chemical properties which make CFCs so useful on Earth are the very same ones that make them so destructive in the ozone. CFCs are incredibly stable chemical molecules with lifespans from 50 to 200 years. 99% of them will drift intact into the stratosphere and the ozone. Here, the CFC molecules are unprotected against ultraviolet rays from the sun. The UV radiation breaks apart the molecules, freeing atoms of chlorine. A single one of these atoms can set in motion the destruction of as many as 100,000 molecules of ozone. The peculiar dynamics of the South Pole are apparently a spectacular catalyst for this chlorine chemistry. During the dark Antarctic winter, the air over the continent is isolated from more temperate atmosphere by whirlpool-like winds. This isolation allows air inside the vortex to become so cold that it forms clouds in the stratosphere, a phenomenon that occurs almost nowhere else on Earth. The ice crystals that make up these unique clouds convert the harmless chlorine atoms from CFCs into chlorine monoxide, which is very effective at destroying ozone. In August, when the sun returns to Antarctica, its UV radiation lets large-scale destruction of the ozone begin. The process subsides in mid-October when the stratosphere becomes too warm to form clouds. During this period in 1987, over half the ozone in the Antarctic stratosphere was lost. The low ozone levels persisted through November. When the polar vortex breaks up at the end of November, the ozone-poor Antarctic air is free to mix with air from the higher latitudes. Scientists speculate that this mixing may dilute the overall ozone content of our atmosphere. The theory may explain why year-round ozone levels over the lower half of the southern hemisphere have dropped 5% in the past 10 years. It may also explain a sharp temporary decline in ozone that occurred over Australia in December of '87. In early 1989, a team of scientists traveled to the North Pole. They were looking for clues to explain a 6% decrease in that region's ozone and a 1.5% to 3% decrease in ozone over the populous northern latitudes that has occurred over the last 18 years. Although the data from the expedition have not been fully assessed, the team found large increases in the amount of chlorine monoxide in the atmosphere above the Arctic. They speculate that ozone loss here may occur more
subtly than at the South Pole. But they know that one long, cold Arctic winter could initiate the same kind of large-scale destruction seen over Antarctica. Scientists are looking for other chemistries that may account for a gradual thinning of the ozone shield all around our globe. But at this point, man-made CFCs are the only known culprit. We cannot alter the natural chemistry that allows CFCs to destroy ozone, but we can alter our use of CFCs. The world's major manufacturer of the chemicals, DuPont, has announced plans to phase them out of production by the year 2000. Other manufacturers are beginning to follow suit. And in a number of world conferences over the past 2 years, nearly 50 governments representing half the world's population indicated their desire to cut CFC usage. In the U.S., President Bush has expressed his support for a phase-out by the end of the century. But even if we immediately stopped all use of CFCs, billions of these long-lived molecules are still adrift in our atmosphere. The destruction of Earth's ozone will continue for years to come.
Greater amounts of radiation will alter our environment. At this point, we can only speculate on what those changes will be like and how soon they may affect us. They may have already begun. But some effects of ultraviolet radiation on humans are predictable. More eye cataracts are one, an increase in skin cancer is another.
This is carcinoma cancer, fairly common, rarely fatal. Melanoma cancer is less common, but is more often fatal, killing 6,000 people a year in the U.S. The incidence of skin cancer is on the rise. The number of new melanomas has doubled every year since 1930. Today, your chances of developing melanoma are 10 times greater than they were 50 years ago. Of course, we spend more time in the sun nowadays and expose more skin when we do. But it's also possible that we may be suffering the effects of increased ultraviolet radiation. There's no proof that today's increasing skin cancer rate is due to a loss of ozone. But if upper-level ozone continues to thin, there can be no doubt as to the future. Dr. John DiGiovanna is a dermatologist at the National Cancer Institute in Bethesda, Maryland.
We know quite clearly that ultraviolet light exposure causes skin cancer, and for any individual, the more light exposure that person gets, the greater his risk is going to be. So one would have to deduct from that with the increasing amounts of ultraviolet light reaching the Earth, one would expect the incidence of skin cancer to continue to increase unless individuals become more concerned and aware and protect themselves.
Dr. DiGiovanna and his colleagues won't make any predictions about future cancer rates. That's not their area of expertise. But at least one study indicates there will be 600,000 skin cancer deaths in the next 90 years because of the thinning of the ozone layer.
It took the drought of '88 to spark public concern about stratospheric ozone loss and global warming. Extreme weather conditions made the danger from these theoretical concepts seem very real indeed. But most of us don't need a drought to relate to our next topic. Air pollution is easy to see. It has hung over the skyline of our cities since the dawn of the industrial age. We've watched it eat the paint off our cars and kill the trees in our forests. We've enacted laws to control it. So why, after 20 years of regulation, is the problem worse than ever?
A cheese riddle. Excuse me, Giorgio. What do you get when you add mozzarella to an ordinary tomato? Something to sing about. That's right. Cheese makes it taste better. So don't forget the cheese.
They've launched it.
That's impossible. In today's business battles, you need the latest intelligence. Today's Wall Street Journal. Think we still have time to move?
Maybe.
Call 800-626-8500 for this special Journal introductory offer. 12 weeks for just $29.75 with a money-back guarantee. 12 weeks, $29.75. Call 800-626-8500 now for the Wall Street Journal.
Allergies itch, make your nose run, make you miserable. You need new Sinutab allergy formula for frequent sufferers. It works for 12 full hours to help stop the itching, the sneezing. Sinutab allergy helps stop it all.
These words from our 97 sponsors.
When you see this, you know it's time for the Weather Channel. The fastest way to get the weather you need when you need it. That's the Weather Channel.
We can't yet point to certain environmental changes and say that they're due to the greenhouse effect or loss of ozone, but the effects of air pollution have been widely documented. Acid rain is one of the best understood pollution problems. It offers a clear-cut example of how our activities have interacted with Earth's dynamics to destroy the environment.
When it rains, the atmosphere is cleansing itself. Whatever has been released into the air washes back to Earth. This is why we have acid rain. We burn fossil fuels in both industry and transportation. Two of the many byproducts of this combustion are sulfur dioxide and nitrogen oxide. There are natural sources for these airborne compounds, but man is by far the greatest contributor. Some of these materials fall to the ground in the form of small, dry particles. Others are swept up and incorporated into growing cloud formations. Somewhere along the way, the sulfur dioxide and nitrogen oxide undergo a transformation. Whether it is a photochemical process driven by sunlight or a wet chemical process taking place in the clouds is uncertain, but the end results are sulfuric and nitric acid. When precipitation forms, the acids are swept out of the atmosphere and back to Earth. This acid rain may fall in the form of hail, snow, ice pellets, or rain. When determining the impact of acid rain, scientists consider the acidity of fallen dry particles, fog, frost, and other methods by which the atmosphere washes itself clean.
Whatever form it takes, acid rain devastates the environment. Its effects are part of the growing body of evidence that the pollution controls exercised for the last 20 years simply aren't enough. Janetta Jones takes a tour of the damage and explores today's research on the problem.
Decades ago, it was discovered that the lakes of Scandinavia were dying. The waters were becoming more and more acidic. The cause? Acid rain. Even today, Norway's rainfall remains highly acidic. The source? Pollution from England's coal-burning industries blown from across the North Sea. In Greece, irreplaceable treasures of another kind are threatened by local pollution. The art from which man has drawn inspiration for centuries is dissolving. This type of corrosion threatens architecture and statuary in industrialized cities throughout the world. In Los Angeles, the air contains 3 times the levels of ozone that is considered humanly safe by the Environmental Protection Agency. Ozone is a toxic gas which causes scar tissue to form in the lungs. Over 60 U.S. cities exceed the EPA standard. Air pollution, particularly ozone and acid rain, has become one of the major environmental issues of our time. The rate by which we are changing the chemistry of our atmosphere has made air pollution an international political concern. Canadian Prime Minister Brian Mulroney addressed the U.S. Congress this past April on acid rain.
In Canada, acid rain has already killed nearly 15,000 lakes. Another 150,000 are being damaged, and a further 150,000 are threatened.
Canada's acid rain problem is thought to be caused by pollution from U.S. industries. This is a pH scale of acidity. It is used by chemists to indicate the strength of an acid. The lower the number, the more acidic the substance. Distilled water has a pH of 7, which is neutral. Pure rain has a pH of 5.6. The average rain in the northeastern United States has a pH of 4.2. Rain is defined as acidic only when its pH falls below 5.6. The pH scale is logarithmic. For example, a pH of 4 is 10 times more acidic than a pH of 5 and 100 times more acidic than a pH of 6. This map shows the distribution of acid rain to be the most severe over northeastern United States and southeastern Canada. The lakes and streams of this region are extremely vulnerable to acidification. There are many factors that determine whether a lake or stream will be adversely affected by acid rain. In the Adirondacks of western New York, the soil and lake floors contain granite weathered from the mountain slopes. This soil composition has very little ability to neutralize acid. The area's rainfall is one of the most acidic in the country, with a pH level of 4.1. The acid rain drains into the lakes unbuffered. The fish population changes. Those species unable to adapt die. In many lakes in the Adirondacks, the aquatic life has been greatly altered or has disappeared altogether. But not all lakes react similarly when exposed to the same levels of acid rain.
Acid deposition resulting from combustion of fossil fuels influences aquatic ecosystems in a negative way, especially in areas where the soils in the drainage basin have limited acid neutralizing capacity. So it isn't as though every lake in the country is going to become acid, but rather that some lakes in some locations with certain types of soils are being acidified or have been acidified during recent decades.
The Adirondack lakes are being treated with lime. The lime will compensate for the soil's inability to neutralize acid. Lakes in other parts of the country fare better because their soils have greater acid neutralizing capabilities. But this protection may not last forever.
We have gradually overcome the capacity of the soils to neutralize acidic substances. And we're concerned in the present decade because we've overcome acid neutralizing capacities of soil systems in more and more parts of the country.
Aquatic systems are fragile. Any changes in the water chemistry can be detected early. Because of this, the impact of acid rain on our lakes and streams has been fairly well documented. But another more subtle symptom of destruction may be more difficult to study. High elevation forests in New York, Vermont, and as far south as the Carolinas are dying. A similar phenomena occurred earlier in Germany's Black Forest. The die-off was so quick that scientists called it Waldsterben, or forest death.
In the mid-1980s, there's been started to be a very real concern about the loss of forests in Germany and other parts of Central Europe, and acid rain was identified as the major cause of that decline and that loss. When we started looking at similar forests, forests dominated by spruce and fir like we have in the mountains of eastern North America, you saw a very similar pattern of decline. So people thought it might be due to acid rain.
A mountain range bathed in clouds may be breathtaking, but for the forest it may be hazardous. Clouds contain highly concentrated levels of pollutants, much higher than rain. But it is difficult to determine how much damage cloud exposure and rain are doing to the forests. Air pollution, including acid rain and ozone, may just be one more stress that the tree must cope with for survival.
We don't know yet the direct cause and effect. That is, we don't know that this molecule of pollutant is doing this amount of damage to the forest. And frankly, we're being asked for short-term answers. We can't study a 200-year-old tree in 2 years and get a meaningful result. But I think we are, in the way we're looking at the problem, trying to evaluate how natural factors are affecting forests, how the air pollution, acid rain, and ozone are affecting those forests. We're getting closer to trying to factor out what the real role of the pollutant is versus something else.
Research underway at North Carolina State University is looking into the long-term effects of both acid rain and ozone on pine forests. The trees are grown in climate-controlled enclosures and exposed to varying degrees of pollution.
Some of the work that we're doing is under controlled environments so that we will be able to specifically treat a plant with a pollutant, a known dose of a pollutant, and to match that dose against the amount of growth change or damage to the tree.
In other research underway at the university, Dr. Reinhardt gauges the effects of different forms of pollution on plant growth.
Pollutants that we're studying in our program are ozone, sulfur dioxide, and nitrogen dioxide. We know and have found out that ozone is the most damaging of those three pollutants to plant growth and development. And it's that type of interaction, the interaction of ozone with acetic rain, for instance, or any of the other pollutants with acetic rain, that we're primarily able to study here in the greenhouse location.
Research has proven that acid rain has very little effect on agricultural crops, but that is not true for ozone.
So we've known for a long time that crops were affected by ozone, but we've we had not done a major study, field study, on COPS until 1979 and 1980, when we started the National Crop Loss Assessment Network program. It ended up being an economic study in addition to looking at yield losses. And the estimates are around $1 to $5 billion lost annually from some of our more important agronomic crops.
The research being carried out at North Carolina State University reflects scientific efforts across the northeastern United States to define the magnitude of our air pollution problem and its impact. The body of knowledge that is accumulating will help mankind enact political and economic measures to begin to remedy the air pollution problems we face.
I think we will have just overwhelming circumstantial evidence with very good experimental evidence to say that pollution is there and it is causing some change in the ecosystem, and that it's more important to control now rather than waiting for that last little bit of uncertainty to be resolved.
Air pollution and acid rain, the greenhouse effect and depletion of stratospheric ozone. Scientists are working to resolve uncertainties about all of these issues. So what do we do in the meantime? In a moment, we'll hear powerful testimony against continuing on as we have in the past.
For years now, we've covered the weather better than anyone. Now, let the Weather Channel cover you better than anyone with this versatile golf umbrella for only $19.95. With its sturdy construction, it gives you great protection from the elements anywhere, at the golf course or the game. The Weather Channel golf umbrella is big enough for two. Take it along on a picnic or just to the office. The super strong fiberglass shaft and solid wood handle make the Weather Channel golf umbrella lightweight, durable. It's constructed with colorful blue and white 100% nylon panels and boldly printed with a Weather Channel logo. So when you hear, "There's a 90% chance of rain," you need the Weather Channel umbrella. For years now, we've covered the weather. Now let us cover you.
To order the Weather Channel umbrella by credit card, 1-800-541-5700. Or send check or money order for $19.95 plus $3 shipping and handling to Seasonal Solutions, Box 6348, FDR Station, New York, New York, 10150. Call 1-800-541-5700.
It is understandably difficult to feel much urgency about these environmental threats when we're sitting comfortably at home, surrounded by a nice green landscape, breathable air, drinkable water, and edible food. So I want to take you to a place where the worst that could happen, happened. A place that bears the deep and lasting imprint of our industrial culture. Liz Jarvis tells the story.
The Main Street, Ducktown, Tennessee. A quiet street in a quiet town. Nearly 600 people live here, where the hills of Tennessee meet Georgia and North Carolina. Those hills are quiet now, too, but it hasn't always been that way. This is the Copper Basin. At one time, they mined more copper ore out of these hills than in any other place in the country. Copper was discovered here in 1843. Soon, mining became the lifeline for Ducktown and the surrounding communities. A job with the mining companies put food on the table for generation after generation. It is the familiar story of America's Industrial Revolution. Copper came to Ducktown, and Ducktown prospered. straight from the mines, the copper ore contained zinc and sulfur. It had to be smelted at high temperatures in order to separate the minerals. Roasting the ore released clouds of sulfur dioxide gas into the air. The gas would combine with water and oxygen and return to the earth as acid rain. Acre after acre of timber was cut to fuel the enormous fires. After 144 years, the mines closed, leaving behind 56 square miles of devastation. Now, although the industry is considered the catalyst, there are a number of other factors involved in this radical change in the environment.
You can't point your finger and say, look what the bad copper company did, because the copper company exploited the resources, but the resources were not all owned by the copper company people. They had to buy, for example, the wood, the timber that was turned into the charcoal that fed the furnaces. Everybody made money. You know, it was an economic thing. The money just came right on down the chain. I can beat the thing.
David Beckler is a founding member of the Ducktown Basin Museum, an organization dedicated to preserving the area's heritage.
Man always wants to simplify and look for the simple answer and place the blame on one group or one organization. And I think here you have an example that definitely shows that one group or one activity was not to blame.
The combination of acid rain, deforestation, and later open grazing would leave the land barren. With nothing to hold the soil, the area's tremendous rainfall eroded the hills on a magnificent scale. The topsoil was swept away, choking the local lakes and streams. In one tick of the geological clock, man created the only desert east of the Mississippi. Since the early 1900s, the basin has been undergoing a healing process. The hills are slowly returning to green. The massive reclamation project has involved mining companies, government agencies, and local efforts. Over 14 million seedlings have been planted during the long, expensive experiment.
We are fortunate that we have the beauty of the mountains and the rivers and the streams, and that we've been able to reclaim all of this. But if it all becomes covered and there's none of that dramatic eye impact to see, then we're going to miss a grand opportunity, in my opinion, to teach a lesson that must be learned.
Here in these hills, scarred and poignant, is a microcosm of man's ability to destroy and then rejuvenate his environment.
I see Ducktown as a classroom for anybody to come and see. They can say, hey, I saw those open gullies. I saw those hills without any form of vegetation on it, and this can happen today.
Environmentalists say it may be 100 years before Ducktown fully recovers, but the good news is that the renewal process is working. It may be much more difficult next time to correct man's mistakes.
Mr. Garfield, welcome to Embassy Suites Hotel.
My room.
Here you get a suite for about the price of a room at most Marriotts or Hyatts.
Beautiful. Don't change a thing.
The living room, sir.
Love what you've done with this room.
The bedroom.
This is great. I need my space.
And of course you'll want to take advantage of Embassy Suites' free breakfast.
Food.
Served every morning.
At Embassy Suites, you don't have to be a fat cat to enjoy the sweet life.
I resemble that remark.
like the people of Ducktown, we are all profiting from our industrialized lifestyle. And like the people of Ducktown, we all bear the responsibility for the damage it's doing to our environment. If hindsight is 20/20, then let's look to Ducktown for direction on how to proceed with the future. The mindset that has allowed us to treat our Earth as though it were a lifeless rock must give way to a perspective that recognizes Earth as a living planet. But with that new perspective comes the responsibility to safeguard Earth against our own excesses. This is a global problem. Hopefully, we're seeing the beginnings of a global solution in the World Government Conferences of the past 2 years. But we as individuals can be part of the solution. Dr. Michael Oppenheimer explains how.
People should be out writing their congressmen, calling those congressional offices, making people in Congress know, making the administration know that this is a priority. But beyond that, there are steps the individual can take to limit their little contribution to the problem. Where does fossil fuel use go to? What are the energy uses, and how can human beings limit those energy uses? Well, we use electricity, we use light bulbs, we use appliances, we drive cars. Cars in the United States contribute about 1/3 of the greenhouse problem. Electricity use gives us about another 1/3. Those are the places to go.
I'm Charlie Welsh. Thank you for joining me for this special presentation of the Weather Channel.
Join us next month for a look at our diminishing shorelines, the shrinking of America. Another special presentation of the Weather Channel. Stay tuned now for your local forecast.
We've had hail before, but this was the biggest we've ever seen. It was a very frightening experience.
It sounded like somebody was out here with a baseball bat pounding the roof.
The hail was just terrible, and I was really scared. I really was.
Allstate checked out our car, gave us an estimate, wrote us out a check right there.
They were so fast on the job and so efficient.
With Allstate, you do not have to worry.
You're in good hands with Allstate.
A member of the Sears Financial Network.